Welcome. Let's take a look at base E and natural logs. So the natural base, or E, is an irrational number that comes from increasing compounding. This is approximately what it is: 2.71828, so on. Now, it's usually used, or primarily used, for exponential growth or decay. It's used in the financial world, and it's also used for things like population growth. So we'll have some sample problems with those types of things later. You find it in the calculator underneath natural log. It's the inverse of E. So you'll often see a natural log key, ln, and then the second function being E. So it depends on the calculator though. This little diagram, a thing that I got once out of a book, shows how using the growth formula, the more often you compound, the closer you get to that 2.71828 number. Okay, so it's primarily a continuously compounding number used for that. So let's talk about some ways to use it. Okay, well, one thing here that this shows is if we have e raised to the power of x, you can treat it just as if, if you do log, that's base e of 43 is equal to x. So that would be 2 point, well, when you figure out then, you put this into the calculator, because now log and e cancel out, or RLN, I shouldn't say cancel out. The LE is the same as LN. So I could have rewritten that as simply LN 43 of 43 equals x. But over here, I put the x first. And then because log base 43, or natural log of 43, is found on the calculator, on that key, you can calculate it, and it comes to 3.7612. So if you do e raised to that power, 2.71828 raised to that power, you would get approximately the number 43. Now over here, an example of it, or another example. Okay, let's take that e to the x. So I'm going to rewrite it now. So it's log using base e 16 is equal to x. And log e is natural log. Now you can then put that in the calculator and see that x is approximately 2.7726. Like other logarithms, you go 4 decimal places. And then you can check that by doing e to the 2.7726, and you would find that does approximately come to 16. Check. Now we can go the other way. If you have natural log, you can change it so it's an exponential form. Here we had an exponential form, and we changed it to a log and natural log, and we're able to solve because of that. So now we're going to rewrite this one in exponential. So natural log is log E8, so these are the same. Then we take the E and push the power, the 12 up as a power, equal to x. Then this is the calculator. So we can figure out what x is by then just putting that in the calculator. You get 162,755. Okay, let's do the same thing over here. That's log base e of x is equal to 7.5. X is equal to e to the 7.5. X is approximately 1808.04. Okay, a couple of these need circling. Okay, now let's look at a couple of things we can do here in order to solve for it. The fact that e and natural log, or log of e and natural log are all the same, helps to solve these things. So here for this one, okay, I'm going to rewrite it. So that's the first thing. I'm going to change it. And that means that I can do, for the 7 here, going to be log 7, but we use e for the base, is equal to 2x. Okay, now LE is natural log, and we divide by 2. I divide by 2, x is equal to the natural log of 7 divided by 2. And when you put that into the calculator, x is approximately 0.9730. Okay. There's another way to look at doing this too. So I can take this original, I can apply natural log to both parts, sides of it. Okay. When you do that, one of the rules is that natural log of e cancels itself out. And that's because it's the same thing as log base e of e is what it's showing. And then when these are the same, that means that the whole thing is equal to 1 essentially. So now we have 2x is equal to the natural log of 7. Divided by 2, we have x is equal to natural log of 7 divided by 2. Same thing. So x is approximately 0.9730. So this next problem is actually a similar concept. We're going to apply natural log. In fact, I'm going to do it this way. Let's apply natural log to both of these. Natural log and e cancels out, so it becomes 2x plus 1 is equal to the natural log of 35. Subtract 1 and divide by 2. So first I'm subtracting 1. And then I divide it by minus 1, and then divide it by the 2. Okay, now let's move on from here. Right now, let's solve using this e to the ln x. So here, what we do is we apply e by raising e, or raising both sides to the power using e. Okay, now this setup, e to the ln, essentially cancels itself out, so that whatever is here becomes the actual thing that's left. So we have 3x is equal to e squared, so that means we'll divide by 3. Okay, so x is approximately 2.4630. Over here now, I'm going to do the same thing. I'm going to put both of these to the power of e. That means that knocks itself off. X plus 5 is equal to e to the 4th. And then I'll subtract 5. 4th minus 5. And that means x is approximately 49.5982. And you can check it by putting it back into that. If I put x in here, so it's approximately 50, I get 55, and then that result in approximately 4. Okay, now let's look at solving some others that have a little bit more to them, more steps. The first thing to do is to clean these things up. You want the term with the e by itself. So that means the first thing I need to do is subtract 2. And so that gives me 3e to the 2x is equal to 8. Let's divide by 3. E to the 2x is equal to 8 over 3. And this is where now we'll apply, put 8 over here a little bit more. Okay. So what we're going to do next now is apply natural log to both sides. It means that cancels itself out there. 2x is equal to the natural log of 8 over 3. And then we're going to divide that by 2. is equal to, or approximately equal to, the natural log of 8 over 3. And we divide that by 2. What that results in, x is approximately 0.4904. The next problem over it is the same concept, but here we had an e, here we don't. Here we have natural log. Right, so let's look at what we do here. Okay. So first thing I can see here is I can divide both sides by 5. So I get the natural log of 4x plus 1 is equal to 14 over 5, which is 2.8. So now I'm going to get rid of the ln by raising everything to the power of e. Okay, natural log of 4x plus 1 is equal to e to the 2.8. Okay. This is one of those things where that also cancels itself out. Can't seem to get that in there. Stay. There, that cancels itself out. And we get the 4x plus 1 is equal to e to the 2.8. So subtract 1 and divide by 4. And x is approximately 3.8612. All of this can be put into a calculator. Okay. Now, here are a couple to practice. These are very similar to the others. Go ahead and do these for a moment. Pause the video, and then just come back to it when you're done. For me, it'll just be about 3 seconds though. Go ahead. Okay, welcome back. So here, the first thing I'm going to do is to clean it up. And then there's the 8. I'll divide by 8 as well. So I have e, x plus 3 is equal to negative 14 plus 21 is a 7. And divided by the 8, 7 over 8. Okay, so that's where we stand so far. I am going to apply natural log to both sides. That means this will cancel, so we'll get x plus 3 is equal to natural log of 7 divided by 8. And then we'll subtract 3 from both sides. And then that we can put into a calculator. So x is approximately negative 3.1335. And then you check that by putting it back in up here. About negative 3, so we get about e to the 0 or 0, or 1 rather. And that gives us 8 minus 21. Right? So it's not quite negative 14. That's about what? Negative 13. 8, 9, 10, 11. Yeah, negative 13. It's reasonably close. So you can tell that rounding affects that. If I had the exact number, we would get a lot closer to it. Next one now. I'm going to clean that up by dividing by the 15. 45 divided by 15 is a nice easy 3. So what we're going to do here is we're going to raise both of these to powers e to the power on both sides. And what that allows us to have, since that cancels out, is 9x equals e cubed. And we divide by 9. X equals e cubed over 9 is approximately 2.2317. So that should help with using natural log and E. Remember, first always clean up the problem. So it's just the E or the natural log that's by itself with some number, of course. All right. So hopefully that helps. Thank you for watching and listening.